Today we're going to cover 8.2, which is the unit circle and find the exact values. We need to learn some things about what a unit circle is in order to be able to use one. A unit circle is a circle with a radius of 1 and the center at 0, 0. And because of that, the equation is x squared plus y squared equals 1. And we get that from the standard form of a circle, which we did in Unit 7. That 1 could be 1 inch, could be 1 foot, doesn't matter what it is just 1 unit, and that is why it is called a unit circle. To find the exact value, we need to be able to identify what reference angle we're talking about. That's, remember, the acute angle formed between a drawn angle and the x-axis. We need to know what the terminal point is on the circle. And the cosine will always be your x-coordinate of the terminal point, and your sine will always be your y-coordinate. We drew our unit circle, and when we did that, we color-coded. So anything with a reference angle of 30 degrees, we drew in blue. Anything with a reference angle of 45 degrees are all in red, and green are your 60-degree reference angles. Degrees we put on the inner circle, radians we put on the middle circle, and your terminal points for sine, cosine, and sine we put on the final circle or the outer circle. Remember, just like XY goes in alphabetical order, cosine, sine goes in alphabetical order. So if you're confused at which one it is, just remember it's alphabetical order. We use our special right triangles to come up with our trig values that made these lines. Just because the degree is on the inner circle and the radians or terminal point are on the other circles, they are all 1 unit away. I spread them out over the 3 different circles so it's easier to read instead of cramming them all in one little spot. So they're all interchangeable. You just need to know how to find the degree and match it with your sine and cosine function. So let's review what our special right triangles were and our values for those. So for our 30 degree or pi over 6, so all of our blue lines will have a sine value of 1/2, a cosine value of the square root of 3 over 2, and therefore the tangent will be the square root of 3 over 3. All of our red lines on our unit circle are 45 degree reference angles. So that means the sine and cosine are both square root of 2 over 2. And the tangent will be 1. All of our 60 degree reference angles or pi over 3s have a square root of 3 over 2 for your sine, 1/2 for the cosine, and square root of 3 for the tangent. So we need to know where things are positive. So to do that, we have our XY axis. And we need to remember that it's all students take calculus. So that is the acronym we are going to remember. And we always go counterclockwise, just like we name the quadrants. So what does that tell me? That tells me that all trig functions are positive in this quadrant. Sine is the only thing positive in the second quadrant. Tangent is the only thing positive in the third. And cosine is the only thing positive in the fourth. So as long as you can remember your three sets of reference angle values for sine, cosine, tangent, and where things are positive, you have your entire unit circle. So we are going to use our unit circle and answer the questions in example 1. So as you can see, I have pulled up my unit circle. You need to have yours out on your table. It says, what is the reference angle for an angle of 240 degrees? So I find 240 degrees on my reference or on my unit circle. It is the green, and remember your reference angle is how far past 180 am I, or how far away from the x-axis am I. So green ones, so these are in green, or your 240 is in green. And to find it, remember you take your angle and subtract 180. So you get 60 degrees, or remember that all of your green lines have a reference angle of 60 degrees. Next, what is the reference angle for the angle of 3 pi over 4? So I find 3 pi over 4. That is in red. So I know from up above, all my red reference angles are 45 degrees or pi over 4. Okay, we are going to keep the units consistent. So if it gives it to you in radians, answer it in radians. If it gives it to you in degrees, we will answer it in degrees. Let's take a look at C. So you'll notice with C it says, what is the reference angle for an angle that is of a negative 750? Well, if you look at my unit circle, I don't have any negative angles on there. So what I am going to do is I am going to take negative 750 and I am going to keep adding multiples of 360 until I get to a positive angle that is between 0 and 360. So in this case, I have to add 3 of them. When I do, I get 330 degrees. So I'm going to come over here to find 330 degrees. That is blue. And therefore, I know that my blue lines are all 30-degree reference angles. While we're here, let's do F before I have to go or scroll back over. It says, if you are at a terminal point of 0, 1. So let's find on my unit circle, where is 0, 1? So 0, 1 is right here. Okay, that is 90 degrees. And I move 300 degrees. So I'm going to keep moving, and I'm going to do that for 300 degrees. So I'm going to take 90, and I add 300. So that gets me 390. Well, I know I don't have a 390 degree on there. So I need to subtract 1 full circle. So going 300 more degrees will land me back at my 30-degree spot. Let's take a look at the last 2 on this page. So if I look at D, it says, what is the terminal point for an angle of 510 degrees? Again, 510 degrees is not on my circle. So I need to go ahead and subtract 360 till I get it on my circle. So it is 150 degrees. So I'm going to come over here. Here's my 150 degrees. So here is my terminal point. And I am just going to write that coordinate down. So it is negative square root of 3 over 2, comma 1/2. When they ask for the terminal point, they want the whole thing. So what is the terminal point for the angle of negative pi over 4? Again, that's a negative, so I need to get it within one circle. So I'm going to add, instead of 360, I'm going to add multiples of 2 until I get there. So I'm going to add 2 of them. So I do negative 9/4 in my calculator plus 2 times 2, which will get me 7 pi over 4. Again, treating pi like it's a variable. So 7 pi over 4 is on my unit circle. It is right here. So here's my terminal point. So it's square root of 2 over 2, comma, negative square root of 2 over 2. So let's take a look at the back side. We're going to use our unit circle along with some other information to find values that aren't on my unit circle, but I can find them that way. So first, let's go over the new information. Steps to find the exact value of an angle. Some answers contain radicals. No fraction or fractions. I don't want any decimals. If you give me decimals, it's going to be wrong. Everything must be exact values. Make sure your angle is between 0 and 360 or 0 and 2 pi, because that's what's on my unit circle. If not, we're going to add and subtract 360 or 2 pi until I get it there. We will then locate the angle on our unit circle and look for the terminal point if finding sine or cosine. Because if you're finding sine or cosine, that's the answer. If you are finding one of the other 4, because there are 6 trig values in all, and that's something that we haven't talked about. You are familiar with sine, cosine, tangent, but the other 3 you're not familiar with yet. So we have tangent, which you can find as doing sine divided by cosine. Your cosecant. So CSC is your cosecant. And that is the inverse of the sine, so it's 1 over sine, or the reciprocal of the sine. Your secant is the reciprocal of the cosine, and your cotangent is the reciprocal of your tangent. So these 4 equations you do need to memorize. You need to know which one goes with which, and we're going to be finding those. If finding the exact value of a quadrant angle, so one that lies on a x or y axis, we are going to just use the value of the terminal points. So let's pull back out our unit circle, and we're going to do some of these. So this first one is sine of 135 degrees. So I look on my unit circle, I find 135 degrees. Sine, so it goes cosine sine, is my y coordinate. So it is simply just square root of 2 over 2. Okay? I just use my unit circle to find it. So for this next one, I need to look at hold on. Let me zoom out a little bit. Hold on. Okay, I wanted to make sure I could pull up the equations. So if I look at cosecant, cosecant goes with the sine. So what I need to do is I need to figure out what is the sine of 210 degrees. So I come over here, 210 degrees right here, sine is negative 1/2. So then that means the cosecant of 210 degrees is the reciprocal. Remember, reciprocal just means I'm flipping it. So that is 2 over negative 1. So that is just simply negative 2. And that is how we are going to go about doing all these. Okay? So if I have cosine of 450, 450 is not in my unit circle. So I need to take 450 and subtract 360. When I do, I get 90 degrees. So look at my unit circle. 90 degrees is right here. The cosine is my x-coordinate, so it is simply 0. Okay, tangent, again, I have negative 780. So I need to go ahead and add 3 full circles to that to get it in a positive quadrant. So I get 300 degrees. So really I'm trying to find the tangent of 300 degrees. So 300 is right here. Notice it is green. So I can use my green reference angle from the front part of this note sheet to know the tangent of anything green is square root of 3. Now I just need to decide if it's positive or negative. So remember, this is all students take calculus. So the only thing positive in this quadrant is cosine. Therefore, tangent will be negative. So it is a negative square root of 3. So let's look at C, or E, which is secant of 390. So first thing I do is take 390, subtract 360. So I get 30 degrees. Then I look up here, secant goes along with the cosine. So let's figure out what is the cosine of 30 degrees. So I find 30 degrees on my unit circle, and the cosine is the x value. So the cosine of 30 degrees is the square root of 3 over 2. So the secant of 30 degrees will be the reciprocal. So we flip it, 2 over the square root of 3. We cannot leave a square root of 3 on the bottom. So we have to rationalize it, which means multiplying top and bottom by the square root of 3. So when I do, I get 2 square roots of 3 all over 3, because square root of 3 times square root of 3 is 3. Okay, if I look at cotangent of 180, so first of all, cotangent, if I look up top, my formula is cosine over sine. So 180 degrees is this point right here. Your cosine is your first coordinate. So this becomes -1/0. Can I divide by 0? No, I cannot. So when it's divided by 0, it is undefined. So the cotangent of 180 degrees is undefined. Okay, it is not nothing. It is not 0. It is undefined. That is the only option for the answer. Sine of 240. So why don't you pause the video right here, do these next two real quick, and I'll come back and go over them with you. Okay, so hopefully you were able to find the answers. So if I go to 240 degrees, that is right here. The sine is my y-coordinate. So it is simply -√3/2. Secant of 120. So if you look up above, secant went with cosine. So I need to find the cosine of 120. So here's 120 degrees. Here's the cosine. So that is -1/2. The secant then is going to be the reciprocal. So it's 2/-1, which is -2. Okay, looking at this bottom row, we now have radian measures. It is not any different. Okay, your unit circle has radians. So let's see what we can find. So if I look at 7 pi over 6, so I am finding 7 pi over 6. It's right here. Okay, we know in this quadrant, tangent is negative. All students take calculus, so tangent's negative. So 7 pi over 6, that is a blue reference angle. So that gets me, tangent is positive. I don't know why I said negative. Tangent is positive. All students take calculus. So blue reference angle, that is your 30-degree reference angles. So you look at the blue on the front of your sheet and you will see it is √3/3. And it is positive because in quadrant 3, tangent is positive. 5 pi over 3. So I find 5 pi over 3 is right here. I want the cosine. It's the x-coordinate. So that is 1/2. Sine of 7 pi over 2. Well, 7 pi over 2, 7 halves is 3.5. That is above 2. So I need to go ahead and subtract 2 from it. So I get 3 pi over 2. That is a quadrant angle. So here's 3 pi over 2. The sine is your y-coordinate. So it is simply -1. Last one. Again, I have a negative angle. So I'm going to go ahead and add 2 of the 2 pi's to get me positive. When I do, I get 5 pi over 4. So secant from up above goes with my cosine. So the cosine of 5 pi over 4. Come over here, 5 pi over 4. Cosine is a -√2/2. So to do the secant, we invert it. Okay, we do the reciprocal, so that means it's a negative 2 over the square root of 2. Again, I cannot have a square root on bottom, so I need to multiply that by square root of 2 over 2. So I get negative 2 times the square root of 2 all over 2. If you can reduce, you must. So in this case, my square root of 2's cancel out, or my 2's cancel out, and I just get negative square root of 2. So make sure when you're doing these, you're showing your work where necessary. If you're just reading it off your chart, there's no work to show. But if you have to do some work, make sure you're showing it. I'll know which ones those go for. If you have questions, let me know.